In our first exercise for this week, we're going to focus on time series data analysis. As you can probably guess, the term time series refers to data that is collected and presented in time order or chronological order. To illustrate the common themes of working with time series data, we're going to take some personal finance data and dissect it using a feature in DAX called time intelligence functions. We'll examine income and expenses on a weekly, monthly, and yearly basis, and we'll also look at how you can do running or cumulative totals, year-over-year comparisons, and other useful techniques when analyzing data over time. With this next sequence of videos, instead of having you build a Power BI report from scratch, we're giving you one that's already in progress. The Power Query steps have already been done, and the data has been imported, and we're just going to focus on the columns, measures, and charts that we need in order to do our time series analysis. This report is located in your Week 3 exercise files called personalfinance.pbix. Just double-click to open it in Power BI Desktop. Once you've loaded the report, let's go to our data view and look at the transactions table that we've loaded. This is someone's personal finance data consisting of their expenses and paychecks for all of 2018 and most of 2019. Our goal is to create a report that gives our user an interactive view of his data so he can understand what he spends his money on, how much money he has left over after expenses, and how his spending and income compare from this year to last year. You can see we've got columns for transaction date, description, amount, type, category, and account. We've got 3 accounts in our data set, a checking account and 2 credit cards. The category column is the category of each transaction, like whether it was paying the mortgage, paying the power bill, buying dinner at a restaurant, and so on. Type tells us whether the transaction was a debit or a credit. The amount is obviously the amount of the transaction. The description just gives us more info about each transaction, and the date is when the transaction occurred. Now, a common task in Power BI development is adding a date table to your model. In fact, it's required for using most time intelligence functions in DAX. A date table provides a continuous, uninterrupted list of dates that covers the entire date range over which we wish to analyze our data. In this exercise, we're using transactions that start on January 1st, 2018 and go until September 30th, 2019. So our date table should contain one row for every date between our start date and end date, with no holes between any dates. If we try to do time intelligence over missing dates, we could end up with erroneous results because many of these functions assume you're using a continuous list of dates. For example, we might think the most straightforward way to start building our report is to use the transaction date column that already exists in our transactions table. However, if we look closely, there are no transactions on January 7th, 2018. There are holes in this column. Transaction date is not a continuous list of dates, so we should avoid using it. Instead, we're going to add a date table to our model, which will give us the continuous list of dates we need in order to perform time intelligence functions. In Power BI, most of the time we use Power Query to import tables into our model from our external data sources. But there's another method where you can create tables based on the data you've already loaded into your model. This is known as a calculated table, and all it requires is a little bit of DAX. To create a calculated table while still on the data view, we're going to go to our Home tab on the ribbon and click New Table. This feature allows us to create a new table in our data model through some kind of calculation rather than doing it through Power Query. As you can see, the formula bar has appeared, and we can enter a formula to calculate our date table. There are 2 DAX functions that can be used to quickly and easily create a date table. They are Calendar Auto and Calendar. If you are working with one date column or maybe only a few date columns, you can use the Calendar Auto function, which automatically scans the dates in your data model to determine what date it should start with and date it should end with. You can also use the normal Calendar function, which allows you to manually set your start and end date if you so choose. For this example, since we've only got one transaction date column to worry about, I'm just going to create my date table as date equals calendar auto with a closed parentheses at the end. We're not going to supply any arguments to this function, so I'm just going to close my parentheses after the function name. No need to put anything between the 2 parentheses. Now, when we hit enter, you can see a new table has appeared in our data view, giving us a unique list of dates, starting at January 1st, 2018, and going all the way until the end of 2019. You may remember me saying a moment ago that our transactions only go to September 30th, 2019, but the calendar auto function does us a favor here. It sees that our maximum date is September 30th, but it kind of assumes that we'll eventually want to see all dates for the year 2019, which is correct. So it gives us those dates as well. Now we have a list of all the dates we need. Next, we need to designate our new calculated table as the official date table for our model. To do so, we simply right-click on its name in our Fields pane and then select Mark as Date Table. This extra step we're doing makes it easier for us to write our DAX formulas by telling Power BI, hey, the person who created the report says that this table is the most reliable source for dates. This little window then pops up and asks you which column in the table should be used as the date, and the answer should be obvious. It's the date column. So we'll select date from our drop-down list and then select OK. Next, let's go to our model view and notice how the date table is now here, but it's not connected to our transactions table yet. Let's just create a relationship by dragging our date field from the date table onto the date field in our transactions table. Now, as you can see, we have a one-to-many relationship from dates to transactions because we have only unique dates in our date table, but our transaction dates repeat inside our transactions table. You may be thinking that creating a separate date table when we already have our transaction dates seems redundant, but it's not. Creating a date table or a date dimension is a universal practice in data modeling because of its ability to give us a continuous list of dates. That continuous list of dates makes aggregating time series data much easier, as you'll find out in our later videos. Also, as we'll see in the next video, date tables open up a lot of new ways to analyze our dates, so stay tuned.